Hello and welcome. Appreciate you joining us this afternoon to discuss this lab versus field presentation. We do want to wait just a few minutes here and we'll get started. We want to make sure more people are jumping on. So just be patient for a couple minutes and we know your time is valuable. We'll get started soon. Okay, looks like some more people have jumped on and we're a couple of minutes after the time slot to get started. So I just want to be conscious of everybody's time and get started here on the presentation. My name is Kevan Mann. I'm the regional sales manager for noise barriers. I have a background in building product and testing and certification. So I have a lot of familiarity with windows, doors, interior finishes, exterior products, anything that's also acoustical in general, wall assemblies. So I love to kind of talk through this stuff, and it kind of makes sense for me to cover, especially the testing side of things, lab, field, and Sal should be joining us a little bit too to talk through our products. So I'm going to get started with the presentation, and we'll talk through this lab versus field STC dependability presentation. So I just want to get started with the kind of the basics of acoustics. Some of you may already know, but it's good to kind of start there. So the first thing to talk about is just the decibel, which is dB, is shortened to that. It's a relative unit of measurement that's used in acoustics, and it's logarithmic. It's used to describe a ratio between measured level and the reference threshold level of 0 dB. And this measurement is considered unweighted. So maybe a more prominent thing when you're thinking of acoustics too then is the A-weighted decibel. So that's how sound is perceived by the human ear. So this measurement is considered weighted, and it's determined by a normalized curve on how the human ear perceives different frequencies. So you have this kind of range of frequencies that can be louder or softer at certain frequencies. So decibels describe that. The weighted curve that we want to talk about is actually here on this next slide. So the A-weighting curve is often used for environmental noise measurement, and it's standard on a sound level meter. So if you're using a sound level meter to measure sound, and you would think of environmental noise, including traffic, trains, aircraft, anything that you would hear out in different environments. So this A-weighting curve can be used as a potential to determine potential hearing damage from repeated exposure to high noise levels. So think of OSHA requirements if you're in in a warehouse or a factory setting or something like that, where you have large generators, you have large machinery that's making a ton of noise. I know I was in a concrete plant not that long ago, and it was so loud. I had to wear ear protection. So it's definitely something that's important, especially when you're kind of working in that environment all the time, to understand the A-weighting curve. More of the basics. So we kind of talked about frequency a little bit. So frequency is also known as pitch, and it's measured in cycles per second. Hertz is shortened to Hz. Sound waves are longer at lower frequencies and shorter at higher frequencies. and labs have to have certain dimensions in order to effectively measure those low frequencies. So when you think of a really longer sound wave at the lower frequency, you're going to need a larger room for that sound wave to be able to travel appropriately and have a certain amount of cycles. So that's why certain labs maybe don't have a reverberation chamber that's large enough to measure some of the lower frequencies. Many times those labs only get qualified to go up to a certain or down to a certain frequency, such as 20 hertz or something like that in the lower frequency range. And then of course, standards will call out specific frequencies that should be measured, and they're known as third octave band frequencies. Talk a little bit more about that when we get into our lab measurements. So in the lab measurements, you have STC, which if you're in this industry at all, you're dealing with doors and windows, acoustical doors and windows. You've definitely heard of the term STC before. It's a single number rating that's calculated using ASTM E413 and E90. This number shows how effective a partition performs against airborne sound, which is human speech, and sound transmission loss, or STL, is the measurement of that abatement of noise in decibels of sound energy through the partition. So in the illustration to the right, you can see the transmission source room kind of blasting the sound through the partition into the receive room, and you're going to see the reduction in sound in decibels and dBA from room to room, and that's going to help you to get that STC number. So you think of STC 50 door or something like that, that would be determined by running this test. So labs have all kinds of advantages. When you think of the lab, you think of a controlled climate. So the relative humidity and temperature are perfectly monitored, and they're kept in a certain level that's going to match the standard that it's measuring to, such as ASTM E90. The building's going to be properly isolated up on isolating blocks. The conditions are predictable, and it's set up per an ASTM standard, and the labs are ISO 17025 compliant. So by having all of these things to the advantage of the lab, you're going to get an accurate measurement, and you're going to see, as we talk about field measurements, something quite a bit different. And so let's kind of move on and talk through the field measurement section. So with field measurements, instead of STC, we have ASTC, which is also known as apparent sound transmission class. It's a single number rating, also calculated using E413, which is the more broader classification, and then ASTM E336, which is going to be the field version of E90. So you're still measuring that airborne sound, but you're just measuring it in the field. So there's going to be different qualifications for that one. So field environments do not have the luxury of that predictability that the labs have, and it's not possible to completely isolate that product that's to be tested. I think in the lab, you already know exactly how that wall performs, or the partition that the product is installed into. In the field, you kind of have no idea. You can look at drawings, you can come up with the best idea of what it is, but you're not necessarily going to know exactly. There could be all kinds of paths for flanking, and that's kind of in this picture here. It shows a source playing, and then that D area might be where your product is, but the F is going to be so that's known as direct noise, and then the flanking is going to be, hey, it's going to go through the walls because they're weaker. Maybe there's no insulation. Maybe it's gone up through the plenum above the door in between rooms or something like that. So flanking is a big kind of enemy in the field, where sound is kind of escaping through different things that you don't want it to. In the lab, you're typically going to blot out all the flanking issues, and you're going to make it very much more controlled and easy to measure. So because of all those differences, when you're looking at field measurements, those results are acceptable at 5 points lower than a lab. So if you think, if it's a lab STC of 50, in the field, it's probably a 45 ASTC for being accepted. If you have something much lower, like a 38 or 35 or something like that, there's likely a flanking issue or some other kind of problems on site. So some difficulties of doing field tests, heard from many people over the years that have been performing these. We talked about flanking a bunch already, so I'm not going to get into that. Office and construction workers present. So if you come into a building, you're trying to run a test, you have a bunch of people that are just working their 9 to 5, or the building's in construction at the time, and the construction workers are very loud, running loud machinery, kind of makes it impossible to do a test. Occupants complain, so maybe you're doing like a test in a hotel or something, and you have someone the floor above that doesn't like you blasting pink noise through the hallways, so that can be an issue. Sometimes there's lawyers present, so if it's a litigation case, you also kind of have them to contend with as well. And then just getting equipment up the steps or up on a lift or something like that to get them to the appropriate area. So there's lots of difficulties in the field just to get the products, to get everything tested correctly. So these are some photos from a riverbank field test that was performed. It was interesting to see kind of the way that the measurements are taken, the microphone outside of that kind of storage closet or office area, and then that speaker there with kind of the multiple angles where it blasts the sound throughout that. So the computer will be set up and everything and power amp, and they'll blast the sound through that at all those different angles to kind of see how much is getting through to the outside. And keep in mind, this flanking patterns can also come into play in these kind of tests. So you try and isolate that sample as best as you can. So some other field issues can be present, a bad installation, maybe someone didn't install the product properly. So improper use of the product, maybe it just wasn't used correctly, propping the door open. Sometimes I know in our products, you can kind of see that seal on the right, it kind of got messed up. And also the seals at the bottom of the door, when you're propping the door open, it can often cause a lot of damage to those and then kind of render the acoustic door to be very ineffective because the seals aren't going to lock in properly. And then also just poorly planned acoustic weak spots. You have walls, plenum spaces, and HVAC area for the noise to go through. So also the nice thing about what we have to offer is our products can be very beneficial to basically take any of those issues that you would experience and help those to be much better just because of the quality of the products and the way they're manufactured. They're made in the USA with quality materials. Most of the products are fully factory assembled. So the hardware seals, glazing, and threshold are all together. When you're putting a door together in the field, you don't have to do nearly as much work. So contractors love that. And it kind of assures that the product is going to be much higher performing because it was assembled and tested in the factory as well. Kind of eliminates that guesswork in the field when you're trying to do different things to figure out, hey, where's the issue? And we sell it as a system in general, so you're not just selling a door leaf or something like that. So there's definitely a lot of benefits with that. The products are not only acoustical, but they're also aesthetic. So, they often look very nice. I like that picture on the right. Is definitely a very nice Alexis door that we sell. So that's a good product. And the industrial options are available too for more economic applications. Not always economic, just because it's a simpler looking door, because you're also looking at doors that are gigantic sometimes that are used in industrial settings. And they're designed by noise control specialists. So we have engineers and project managers that are making sure that the products are very, custom fit for each project. And it's definitely an advantage there. So just going to go on to talk about the products a little bit. So you look at our architectural doors, some of the features with these are their guaranteed acoustical performance on all the products. They're tested at accredited labs. I mentioned earlier the ISO 17025 compliant labs. So they're all accredited, make sure that the results are good to go. You have that adjustable mortise bottom seal that allows the door to adapt to the site floor conditions. This is definitely an advantage when you're talking acoustics to kind of keep that sound from going through. The seals are definitely desirable in that situation. We have split frame assembly that allows that installation into existing openings and makes that work a lot easier for the contractor in the field. There's vision panels that are factory glazed and ADA compliant. The factory glazed portion is really nice because you're not having to worry about glazing them in the field, which can be an issue for some. So it kind of takes that whole thing out of it. There's single leaf, double leaf, and bifold options available. And STC ratings range from 45 to 64. I'm actually going to let Sal join and kind of talk through some of the rest of the products here. Sal, are you able to jump on and talk through the next slide? Okay. I'm going to keep talking. So we have quiet swing architectural. The applications that these are used in is you have studios, performance halls, classrooms, music practice rooms, jury rooms, hospitals, assisted living, SCIFs, auditoriums, audiometric rooms. So definitely a lot of nice applications that this can be used for. The industrial doors, like all noise barrier doors, the hardware seals and hinges are factory installed. Again, a big advantage. The double magnetic seals at the head and jambs is great as well. The custom cam lift hinge design eliminates the need for thresholds. So the cam lift hinges are just kind of these super heavy duty hinges that are very helpful as well. Designed to work with standard building hardware, and they can be factory installed if desired as well. You have guaranteed acoustical performance, and again, range from 45 to 64 with our industrial doors as well. Some applications for the industrial side, we have test facilities and chambers. We have the engine test cells, quiet rooms, product jury rooms, vibration test labs, mechanical equipment rooms, control rooms, conference rooms, secure areas. We have shake, rattle, roll rooms, factory offices, SCIFs, power generation, compressor, and generator set rooms. So a lot of different applications where these can be used, and probably some I didn't name as well. This is an excellent product, the quiet slide door. I love kind of the video. We don't have it on here, but it shows kind of the ease of installation for this one. Motorized doors have 2 motion sensors, 2 3-button operation interfaces on both sides at minimum. You have that single sliding or biparting door option. I'm actually going to let Sal talk through this part because I think he said this is his favorite product.
Yes. Hi, everybody. Thank you for your patience. I've had a little computer issue. So yes, thank you, Kevin. This is actually one of my favorite products. It comes in different. The reason for it is I've seen it from the beginning, the inception of the construction of this door and how it's come together and where it is now. A lot of great benefits about this door that I truly like is the size. The size is not an issue. The load capacity with the new integrated rail system and the safety mechanisms that involve in this door are really unique. A couple of things where most of these motorized doors would come a lot of the other vendors provide these in broken down components. For the most part, these doors come almost fully assembled. The header rail system where the door hangs off of is fully tested and assembled in the factory with all the sensor positions. The only thing that's basically installed in the field is a couple of loose items, is your jambs, your headers, your baffles, and also your slabs. If you have a 10 by 20 door, you're going to have them in slabs of 3 to 4 feet in width, in height by the length of the door. When doors get up to 20 to 30 feet wide, we do like to go to a biparting option. So you'd have 2 motorized sections that would slide in uniform or separately, depending if you only want to open one side of the door. So it definitely is a door that's very unique. Application where most of these are seen: stage and scene shops, TV, production studios, machinery enclosures, machinery equipment rooms, convention centers, concert halls. So a lot of these go into certain areas where they're really pushing a lot of big equipment, so they need the access, but they also need the acoustic rating from the opening. That's where you'll see a lot of these big sliding doors. Here's another great product that I definitely like. I've personally had the pleasure and the opportunity to put these in the field. Are quiet light windows. The testing, the product tested very well in the test lab, and also tests very well. One of our products that tests very well in the field. The frame itself is 12 gauge metal, the frame, so it's a very stout frame, comes with 16 gauge stops. We have multiple types of windows. We have your HM window, your U-shaped window, and your split frame. So the HM window comes fully assembled, glazed, and ready to be installed in the field. Depending on the size, you may or may not want to take the glass out just because of sheer weight, but at a smaller scale, you can definitely put it right into the opening, screw it into place by taking out some of the 16 gauge stops, screwing it right to the opening board, whether it's a piece of plywood or concrete. STC ratings go all the way from a 43 to a 64. Very field performance again is significantly great on this product. Double glaze systems are utilized to achieve the STC rating. So the STC rating, mainly depending on the opening, you may have something that's your wall opening maybe 4 inches, 6 inches, 8 inches, 10 and 12 inches. We can accommodate that. It's made to fit the opening size. Some of the applications locations for this would be the radio, TV studio, control rooms, schools, recording studios, engine test cells, machine rooms, machinery enclosures, factory offices. These windows, when they go in an engine test cell or a machine room or a machine enclosure, we definitely like to beef up our windows to be provided with a blast resistant glass, which is about 1 inch and 1/16, and that's to protect inch and 1/16 or inch and 3/16. And that's to protect the person standing outside of the window itself in case there is an explosion or a failure of the equipment that's performing inside of the unit. Oh, go ahead, Kevin.
Thanks for talking through that part, Sal. I appreciate it. Just wanted to kind of bring it to a close here. So, just kind of summarize some of the stuff that we talked about throughout the presentation. The field numbers, if you remember, they can be expected to be about 5 points lower than the lab results. That flanking can be the cause of a product failure in the field, along with quite a few other issues as well. Noise barrier products are factory assembled, easy to install, lowering that possibility of error in the field. And if you check out our website, noisebarriers.com, you actually found a whole lot of information, test reports, STC numbers, and kind of broken down by the 3rd octave band, so you can kind of see how it performs at different frequencies, lowered, mid, and high. And so yeah, we tend to provide a lot of that information and also just additional information on the products as well. And at this point, we want to open it up to some questions, especially while we have Sal on this webinar. He's very knowledgeable with the noise barrier products in general. So I encourage you to type in any questions you may have in the question field of your taskbar. I'd love to kind of just address them and talk through them today. So we'll stay on here for a few minutes yet and allow questions.
Yeah, we don't have any questions right now, but yeah, we'll hang out for a couple minutes and see if any come through. All right, I don't think we're getting any questions, so if you guys want to sign off, go ahead.
Excellent. Hey, thank you very much, everybody, for joining us. I hope you learned something new today about field and lab testing, as well as our products and how they can be applied. So have a great day, and thanks, everyone.
Yes, thank you.